Alright guys, we're going to talk about the angle addition postulate today, which is actually a very simple thing, and it's going to be common sense to most of you, but maybe some of you guys need to hear this, so we're going to go over it. So as you guys already know, the word postulate here just means fact. So this is a fact that you can use to solve problems that you don't know the answer to. Alright, so the angle addition postulate just says that an angle measure is equal to the sum of its parts. It's very simple. So for instance, if I have this example right here, I have angle LTR right here, and I want to know the measure of angle LTR. But it doesn't give it to me. Instead, it gives me just the two parts that make it up. Well, like I said, the angle addition postulate just simply says that an angle measure is equal to the sum of its parts. So here are its parts. So that means that the measure of angle LTR is equal to whatever the measure of angle, and then this is angle LTS, and the measure of STR, measure of angle STR, are together. All right, that's why we're adding them. So that's the angle addition postulate. The sum of its parts is the whole thing. All right, so now we're just going to turn this into numbers. So this is going to be equal to whatever 71 degrees is, because that's the measure of angle LTS, plus the measure of STR, which is 19 degrees, will give us our answer. And 71 plus 19 is 90. So the answer here is 90 degrees, right? So we would say that the measure of angle LTR is equal to 90 degrees because of the angle addition postulate. If this is one of its angles, if the big angle is LTR and is made up of angle LTS and STR, and we add them together, we'll get the whole thing. Right? Now this works too, even if it has variables. So this one's a little bit different in that this time it actually gives you that you want the measure, or you want to find x, and the measure of CAR is 140. And this is CAR. So this time it actually gives you the sum, and you had to figure out a little bit about the parts. We can still use the fact that an angle measure is the sum of its parts to our advantage. So this time we know that the measure of angle CAS plus the measure of angle SAR plus the measure of angle SAR has to be 140 degrees, because the whole thing, it says CAR is 140 degrees. So we can set that right there, and then we can keep going. So now we know that the measure of angle CAS is 3x, so we'll just replace this with 3x, and then this, it says, is x plus 2, so we'll put that, x plus 2, and then that's got to be 140, right? So then at this point we're just solving equations. So first you should combine your like terms. If you have 3 x's and then you add a whole other x in, well, now you have 4 x's, so we're going to make this kind of come together as 4x, and then we still have plus 2 here, and that's equal to 140. And then we can start eliminating things. So because the x is over here, we want to get rid of everything that's not x. And the first step, if you watch the creating equations video, is to subtract 2 off of each side. This 2 minus 2 is going to be 0, so that cancels. And then over here, 140 minus 2 is 138. So we'll say equals 138. And then this will carry down to be 4x still, because we didn't get rid of that, we just got rid of the 2's. All right, and then we're going to divide by 4. This will cancel, and then you'll just have x over here, and then 138 divided by 4 is 34 and a half. So then we could say that x equals 34 and a half. And we solve that because we know that this whole thing is 140, and that even though these are variables, it still has to equal 140 because it's got to equal the sum of its parts. And that's still the angle addition postulate. All right? Now, like I said, this even works if it's in 3 different parts. So here's one that's in 3 parts instead of 2. All right? But if we want to know the measure of angle SLD, which is this big one, SLD, then we can just add up the little parts to it. All right, so we could do 56 degrees right here, plus 58 degrees, plus 45 degrees, like this. And then you would just solve. So we know that 6 plus 8 is going to be 14, and 14 plus 5 is going to be 19. So we put the 9 here, the 1 here, and we keep going. 5 plus 5 is 10, plus 4 is 15, plus 14 plus 1 is 15. So we have 159 here. So the whole thing, we would say the measure of angle SLD is 159 degrees. Again, because we know that each of these is just the sum of its parts. The whole thing is the sum of its parts, and that part is 56, that part is 58, that part is 45. So we can just add all of them together to get the big thing. All right. Now I'm going to work through 2 examples that you would see on a quiz. Hint, hint, wink, wink. All right. So this is what it's going to look like more than likely on a test or a quiz. Is they're not going to actually, like on these, you can see they actually give you, put it in the slots, what each thing is. But on a quiz, you're going to be expected to label this yourself. So first, you got to know that if it's the measure of angle LMN, well, where is angle LMN? Again, you're just following the points. So angle LMN is this big one, I guess, right here. The whole, so we know now the whole thing, this large arc right there, is 78 degrees because it tells you. All right. Then it breaks it down even farther. It wants to know QMN. So it says find that. So I'm just going to name that X because that's what we want to know. Find QMN right here. This is X. We don't know that, but we want to. And then it says given that the measure of LMQ is 50 degrees. So here's LMQ, and that's 50 degrees right here. And again, we can just use the angle addition postulate. So if we know that this whole thing is 78 degrees, and these are its parts, well, that means that the measure of angle LMQ, this part, smaller part, plus the measure of angle QMN, we know that whole thing there has to be 78 degrees. So now let's put in our values here. This, it says, is 50 degrees, plus this, it says, is X. That's what we want to know. And this is all equal to 78. So now you're just solving. Like I said, so now this is minus 50. That cancels because 50 minus 50 is 0. So the only thing left over here is X. And X equals whatever 78 minus 50 is. So 8 minus 0 is 8. 7 minus 5 is 2. So that must be, X would be 28. All right. So this is one where it gives you the whole thing, and then you have to find about one of its parts. All right, let's work through another example. All right, so this time it's got more variables. So we have the measure of ALK, which is ALK right here. This is X plus 41 degrees, all right? And then WLA, which is WLA, so this one right here is X plus 78, it says. And then it tells you to find x, given that WLK, which is WLK, so this is the big one, is 95 degrees. So now, like I said, you know that, I can kind of continue this out here for a second, you can see what I'm about to do. So this whole thing is 95 degrees, and it tells you two of its parts. So again, we can use the angle addition postulate. So we know that the measure of angle WLK, which is the whole thing, is just equal to the measure of its parts, which is WLA, and ALK. All right, so this is 95 degrees, it says. It says that this, I'm going to put these in parentheses so you kind of see what I'm doing here. WLA right there is x plus 78. And this is x plus 41. So now we have it all set up. So now, these parentheses are not really doing anything other than helping you see what the groupings are. There's no multiplication going on with them, so I can just basically take everything right out of that and rewrite this as everything but without parentheses. So there it is again, and now I can combine like terms. So the x's are like terms, so x plus x can be combined to just be 2x because there are two x's, all right? And that's equal to 95 degrees along with these numbers. So these numbers are going to be like terms. So 78 plus 41 would be, well, let's just work it out over here for a second. 78 plus 41 would be 119. So this is going to be positive 119, like that, all right? And then we're going to subtract, all right? Because now, again, if you've watched the solving equations video, then you'll know that the first thing you should do here is subtract. So we're going to subtract the 119, subtract the 119, like so. And then this will cancel. This will be whatever 95 minus 119 is, and you may think to yourself, well, that's a number that's smaller than 1, because if you only have 95 of something, you can't take away 119 of it. Well, you kind of can, so we're going to try and do that, all right? Now, I'm going to do it in a special way. This is just a method that I like to use. I like to go in reverse when I know it's going to be negative. So I'm going to start with 119, and then subtract 95. Right? So 9 minus 5 is 4. 1 minus 9 you can't do, so you're going to have to take this, put it over here, and that's going to be 11 minus 9, which is 2, like that. Right? And now I just got to remember, like I said, that my answer needs to be negative, because I can't actually take away 119 from 95, so you're going to go below 0. So this is going to be negative 24. So what you get over here is negative 24 equals 2x, because that's gone, and this now is negative 24. And now we're just going to divide. So divided by 2, divided by 2. This cancels, so you're just left with x over here, and then 24 divided by 2 is 12, and a negative divided by a positive is a negative. So you get negative 12 equals x, and that is your answer. So no matter how big or messy this gets, you can always use the angle addition postulate to solve problems like this, because an angle addition postulate just says an angle measure is the sum of its parts. So if you know its parts, then you can use that to find the whole. Or if you know the whole and you're missing one of its parts, you can use that as well. Hope this was helpful.